Hello everyone, welcome to yet another tutorial on interacting with SWAT Plus model in SWAT Plus Toolbox. Now, before we proceed, you're probably wondering, what is SWAT Plus Toolbox? Well, it is just that, a toolbox for SWAT Plus users. It's a free software that allows multiple functionalities to accommodate the needs of various SWAT Plus users. These include getting an overview of your model. You might also run your model with specific settings, as I will demonstrate later. You can perform parameter sensitivity analysis. You can check your model performance with performance indices or visual inspection of graphs. You can perform a manual calibration in the interface, but you can also perform an automatic calibration. Furthermore, you can check your model for potential errors. Now, I'm still developing this part for checking potential errors in the model. So now we only have the hydrology, but this will extend to other variables. There have been issues with calibration in the past. This is mainly due to discrepancies in the units. At first, in early revisions, it was not clear whether the units were in cubic meters per second or hectometers for discharge, that is. And in later revisions, when it became clear that the units were in cubic meters per second, monthly and yearly flows were not correctly calculated because instead of averaging the daily flows, they were just summed up. Now you don't just sum up cubic meters per second. As a result, calibrating for hydrology at monthly and yearly timestamps was nearly impossible. There were also a lot of non-sensitive parameters. In later revisions, most of these issues have been fixed. Now we have units that are consistent. The monthly and yearly discharges are calculated correctly thanks to the SWAT team in Texas, but also non-sensitive parameters are being fixed. A friend of mine from Denmark sent me this nice table which gives an overview of which parameters are currently possible to be calibrated. And this is from a list of parameters that are the usual suspects when it comes to calibration. Now, in this tutorial, we are going to see how we can interact with our model in SWAT Plus Toolbox. Let's dive in. So we open our case study. This is not exactly the same as the one that I've been using in the past. Let's see, QSWAT Plus. Now, the first thing you will notice is that we don't have SWAT Plus Toolbox here yet. That is because we have not installed it. So what we will do is we will download SWAT Plus Toolbox and install it. The link is in the description. I've already downloaded it, so I'm just going to go ahead and install it. Before I do that, I will first of all close QSWAT Plus and QGIS. Okay, now go back to the installation. The integration of QSWAT Plus Toolbox only works if you selected the recommended installation for QSWAT Plus. Installation is just as usual. Click next, and this will install it in the SWAT Plus directory in C. Okay. All right, now click finish to finish the installation. Now we have a shortcut on the desktop, but also we have one here which we can pin to the start menu if we want. Okay, great. Let's open again our SWAT Plus project in QGIS. And open QSWAT Plus. Now look at this. We now have SWAT Plus Toolbox option in our QSWAT Plus. And to create a project, you just click on SWAT Plus Toolbox and you'll see a notice that says this will create a project at, and usually it's within your project. It's going to be somewhere here. Let's go back and click OK. All right, if I want to go back to my QSWAT Plus project, I will just close it and I'm back here to recreate my model. I'll go through the editor if I want to. And next time I click here, it will not recreate the project. It will just open it because it already exists. Another way of doing this is just open the project here, after you have created it, that is, and it will ask you, do you want to load a new SWAT plus Toolbox project to make sure that you're not interrupting important things? Then you say yes, and it will open the project. But let's say you didn't have a project in the recent here. Okay, let me delete that. Let's say that you didn't have a project here and you don't have QGIS installed. You just have txt in out folder. What you can do is you can say create a new project and browse to where you have the txt in directory. Go to the scenarios, txt in out. You select OK. If it's a valid txt now directory, it's going to now ask you to save the project. Now you can save it anywhere you want, but I like to save it inside the project together with the QSWAT Plus project as well as the SWAT Plus editor project. Now I will give it the same name, Robit. And okay, you say save. All right, we have created our project. So there are different ways how you can do this. By the way, if you are looking for some documentation, I'm still working on it, but you can go to the About tab here and click on the documentation link, which will take you to the page that I'm working on. Anyways, back to the use of SWAT Plus Toolbox. The first thing that you can do is to run your model. Okay. Now, sometimes you just want to change the start year and the end year or the warm-up period. You have two options. You can go inside the text in out folder and edit the time.sim file and also the print.prt file and all the other files. But here it is much easier to make these run settings. You can select the beginning year or the beginning date by clicking here, start date, and then you click on top here to go to year selection mode, and I will start in 1993, January the 1st, and I will end in 1996, December 31st. Well, let's make it 1997. 1997. Okay, and I will check my warm-up periods to 1 year. Okay, now you can also change the routing method. So you have the mask income or the variable storage, whichever you are looking for. You can change quickly there, and the PET selection, PET calculation method. You have the Penman Monteith, but you can also choose all these others depending on what you need. All right. You can also go to a print object. You can choose which objects that you want to be printed. You have the model components. These are the general ones, the most used ones, I guess. You have the channel, which you can select which time steps you are looking for to print. Now I'm going to print this at the daily, monthly, and yearly, and also annual average. And I will also need all the other things in annual average because that will help me at a later stage when I'm doing the model checks to have an overview of the model. Without these, then you cannot really inspect your model potential errors. We are using files that come if you select annual average. Okay, so what else do I need? Nutrient balance. I don't need that. I don't need that. Water balance. ET. Yeah, I need the basin ET at monthly. You'll see why, because in my observations here, I have the observed ET monthly for the whole basin. I have the observed flow for daily time step for channel 1 and nitrates. These are in the channel at daily time step for channel number 5. So depending on your observations, then you select whichever you want. By the way, if you want to open your text in R folder, you have a button here that just takes you there. These you can open, but it's much more difficult to open these in Excel. You have to do some text import, but the CSV files are easier to deal with in Excel. So you can just set the switch to yes, and then it will print CSV out. Now, if you want to run your model, you just click Run Model, and it will show you the progress of your model run. So let's see here. It's running from 1993 to 1997 here. Currently it's 1995. By the time this gets to the end, it means it has completed the run. Okay, let's wait. All right, now that's about running SWAT. It's not as many options as in a SWAT Plus editor, but it gives you the convenience. You don't have to go into SWAT edit and rewrite your files every time you want to change a small setting. Now we move to loading your observations and checking the performance of your model. Usually by this time you will have just written your files and created the project, so you will be checking the performance of the model before the calibration. Before you go into checking the performance of your model, there's one thing that is very, very, very important. I cannot stress this enough. You see down here, the date format, it's MMDDYYYY. The month is in the beginning and the day is in the middle. Now, SWAT Plus Toolbox will not work if the date is like this. You have to change the date format. This has to be in DD, MM, YYYY. That is, you have to have the day at the beginning and then the month in the middle and then the year at the end. So let's change this. Go to control panel and then click on change date time or number format, and then you click on additional settings, go to the date tab, and then here you change this to DD, MM, and then YYYY. And once you do that, then you will be assured that your observations are going to be read correctly. But also it means your observations should have the same date format, okay? All right, close that, close everything. Now we can go to observations. All right, so in our observations folder, which I will put on the side here, let me just make this a little bit bigger. Okay, we have observations of, okay, flow at the time step. Okay, so I open one of these files. This is the format that you should have. Let me just close this. All right. This is the format that you should have. If you have any missing data, you should put -99 or -999. Really, any negative number should work. But you see, the date format here for day time step, it's the day, month, and year. And it's the same as what we have in our system. Very important. Okay, now I'm going to close this, and we have seen the format. I don't need to save this again, so just close. Back here, so it's for channel, right? I will select channel. So you have here options. If you are calibrating for landscape units, you select the landscape unit here, or the hydrologic response unit, HRU, or for the entire basin, that means it's the average for the entire basin, then you select this one. Okay, but for flow, it means it's going to be channel, and then it's channel 1, so we say 1. And then here we click to load an observation file. So when we click this one, we can select that this is the file that we're looking for, open it. And then the time step, we select daily. And we can proceed and set that this is flow. Now here I only have these, but I will be adding a few more observations that you can use with the SWAT Plus Toolbox. But for now, it's just flow, ET, sediments, and nitrates, and different forms of nitrogen here. Okay, so once you're done with everything, then you click on Add to Observations Table. What that will do is it's going to show that you have one of the observations here. The file where you can find it, don't move the file, because if you move it, then it will complain that we can't find this file. So keep that in mind. Add the others in the same way, but this time, let's say nitrates, then you go to channel. I know this is observation inside channel, and it's for channel number 5. I select it the same way, open. The time step is also daily. So I say daily observed nitrate nitrogen. Okay. And lastly, I do for ET. Now this is ET for the entire basin. And here it's for the entire basin. You put 1 if you select all basin. In the future, maybe I might change this a little bit to make it less confusing, but make sure that you have 1 here. Now for the observation file, I select the appropriate one. move on to the time step where I select monthly. Next, it's ET. So this is the observed variable that is inside this observation file. The same way I click add. After adding all these files, I can go to the calibration section and refresh. But before I do that, let me split my observation data. You should know the length. Now this one, according to what we saw earlier, is from 1991 all the way to 1999. But we are going to split it into two. The first is the calibration period, and the rest is going to be for the validation period, as we have learned in this series. So I'm going to start in 1992. That's where I'm going to start the run, and then with 1 year warm-up period, that means my comparison is going to start in 1993. So I'll have, yeah, let's just have 2 years. 2 years, 1993 and 1994. That means I'm stopping in 1994. And I will run this, okay? By the way, you can also run within this tab where you're checking the performance of your model. After running, I can click on refresh model performance and I will see how each of the variables is doing. And we see that here we have for daily flows, here we have 0.5, NSE root mean squared is 0.3, and here we have our p-bias. Also, nitrogen here, that's the variable that's in here. It's not performing very well. Yeah, that's usually the case with nutrients. Okay, and here we have the monthly ET. It has a negative NSCE. If you want to check it visually, then you click the on the observation that you want. You see a plot of the observations and simulations. Here in red you have the simulations, and in blue the observations. The same goes for nitrates. And now yeah, this is quite bad for nitrates because the observed are quite low, and yet the simulations show high. And also you can check the ET the same way. And now that we know how to check the performance of a model, we can dive in and say and look into calibration. Before you go into calibration, it's always good to check which parameters you are going to calibrate. There are many parameters which you can calibrate in SWAT. If you go to parameters and then select in the parameters group, set it to all, you will see a list of all the parameters currently that you can calibrate. Well, that should be possible to calibrate. And it's a lot. The question is, which ones do you calibrate? Do you calibrate all of these? There are some which are more influential than others, as we have come to learn. So you will need to start with the sensitivity analysis as a way to filter out which parameters you're going to calibrate and which you are not going to calibrate. So I'm just going to load a number of parameters and check which ones are sensitive, and I'm going to remove the non-sensitive ones and keep the sensitive parameters for use in the calibration procedure. All right, so you select the parameter group. So you select the parameter and you have different methods of change. That means when you are doing calibration, how is the parameter value going to be changed? By percent. So what percent does is that if it is, let's say, positive 10%, it's going to take the value that was already there and then add to that value the 10% of that value. So it's an increment by 10%. You can do with relative change. This is where a value is either added or subtracted. If you have, let's say, 2, that means the curve number that was there is going to be added by 2 if the change is positive, or if it's negative 2, then you have the original number being changed by subtracting 2 from that. You also have another way to change the parameter, which is replace. Now, this one is different from the rest, which are kind of relative in a way. This one, it will just change the actual value. let's say you're calibrating here ESCO. Where is ESCO? Yeah, this is a good example because ESCO ranges from 0 to 1. This is where you would use replace. It means if your minimum is 0 and then your maximum is 1, okay, I'll just put 1.0 to do with that. And then I say add to parameters table. It means the values that you're going to change, you're going to input are going to replace the original one. The default value for ESCO is 0.95, is it? If I'm not mistaken. And then if you set the value to 0.5, it's just going to replace it. It's going to run using 0.5 as a parameter. Use this very carefully though, because if you say you are adding a parameter, the curve number here, and then you say replace value, what that means is that you're going to set the curve number in every single land use to that value that you have in that moment when you're calibrating. And that is bad, because then you are saying that there is no difference between forested area and agricultural area and bare lands and urban area. They will all have the same curve number, which is very bad. So I recommend against using replace for some of the parameters which are distributed in space. So for curve number, either use relative value or percent value. I like using the percentage change. So here you have, as you have seen earlier, a number of demarcations which help you to quickly change, but you can say I will put -40. It's up to you. You can always type in which value which you want. Okay, so I will proceed and add more parameter values. Okay, now as we can see, I have added a bunch of parameters to the parameters table. Now you can add parameters based on what you're calibrating. Let's say you're calibrating for ET, then you put parameters that are more focused on ET, the ones that influence the ET modes. But these ones, in general, they are geared towards the hydrology. Okay, so now I can go to the sensitivity analysis tab. We have already added observations, and in the sensitivity analysis part, you have different methods for sensitivity analysis. You have SWOBO for your amplitude, you have RBDF, and then you have the delta moment independent measure. So you can choose whichever method that you want. I will choose the Fourier amplitude. Notice the number of samples here, it changes with the method. If you select SWOBO, it means you need more runs. If you select a random balanced design Fourier amplitude, then you see it's the same as the seed. And the delta moment independent measure, it's also the same as the seed. Whichever method you want, you can choose that one. In this case, I'm going to go with SWOBO. Okay, so definitely I don't want to wait for 18,000 runs. That's a lot. So I will change a number of samples that I want. And this, let me see how much samples, how many runs. Yeah, that's still too much for me. It's just an example. Normally you need a lot of runs, but for just an example, I will go with less runs. But normally I would do with something more than more than 50 to begin with. But in this case, I'm just going to go with 5. And here, make sure that you are selecting the observation that you want to test the sensitivity with. So if you select, let's say, based on ET, that means it's going to check the sensitivity against the evapotranspiration to check if these parameters are affecting the evapotranspiration. And the same goes if you're checking the sensitivity analysis for nutrients, then you select the appropriate observation. But for hydrology, I'm going to go with channel 1 daily flow. Note that in the observations, you can also add for the same channel at monthly time steps. So you have observations at daily and also at monthly time step. Nothing should stop you from doing that. It's okay, and everything should work smoothly. But I'm going to check the sensitivity for daily flow in channel 1. Okay. Then to begin, I just click on Analyze. This will run the sensitivity analysis based on the options that we have selected here. And now I click and let's wait and see. So as it is running, you will notice that there is something small here. Well, I'm just going to make this a little bit bigger still. Well, I could just maximize it. Why am I not doing that? Anyway, so with every single completion of a run, then this is going to move closer and closer to the end. So you can watch the progress of running the samples here. If you get out of this sensitivity analysis tab, then you can see for every run, it's going to show up to the end. And then it starts again. But this goes to any of the tabs that you visit. If you go to the run model, you can still see that it's running and then it stops and then it runs again. And at this point, if you try to run, it will say you cannot run SWAT because sensitivity analysis is running, which is just to prevent people from making a mistake. Otherwise, it will crash if you try to run SWAT plus in the same texting out folder. And yeah, we can open and see that we selected the CSV here. Here are the CSV files. Okay. Let's see the progress. Okay, I'm just going to speed it up. All right, we see that sensitivity analysis has now finished running, and we have some results here. Interesting results, I must say. Some of the parameters have zero sensitivity. These ones are not sensitive at all. That means we would be wasting time if we try to calibrate the model using these parameters. So the best thing that we can do is remove them. Okay, so the first one is alpha, and then we have OVN. Go to parameters. To remove a parameter, you just click the X on this side. Alpha, OVN, and I think the last one is the RTE. It's supposed to be sensitive, but it just is not. RTE, N, yes. So the parameters that I've removed are not sensitive in this case. Some of them are supposed to be sensitive, but if there is an issue with the SWOT plus executable, in this case, not being able to change really the parameters, that will be worked on, I'm sure, in future revisions. But for now, we can't really calibrate those parameters. So the other ones here, we can sort them. If you click on sensitivity, you can sort them from the lowest to the highest or the highest to the lowest. And we can see these are, by the way, first order sensitivity indices. So as expected, the curve number is the most sensitive parameter in this case, and then it's followed by ESCO and then all the others. But these do not really have a huge influence. In this case, if I wanted to just focus on a few parameters, let's say 3, I would remove the ones on the bottom and be left with the ones on top. If I want to focus on 2, I would remove these 3. So depending on how many parameters you can deal with, then you can remove the ones at the bottom here. So in my case, I'm going to, yeah, I will leave all of them. I will leave all of them here and go into calibration. But that means the priority, in my case, I'm going to give to curve number. If I'm doing manual calibration, then ESCO, because these are the most sensitive parameters. And then once I've calibrated those, then I go to the other ones in this order.